Welcome to Brain Vision.
Welcome to a new problem. This time we have an astronaut in space and they happen to have a mass of astronaut. So this is what's given. We're given that the mass of an astronaut is 68.5 kilograms, and then we're also given that this is, they're orbiting space. That's the astronaut, okay, and the mass happens to be 68.5 kilograms. And the astronaut happens to throw away a tool. We don't know what the tool is, but the astronaut throws the tool this way, meaning that they're going to have a push that way because of Newton's third law. So Newton's third law says the action and reaction forces are equal and opposite. The mass of the tool happens to be 2.25 kilogram, and the tool is moving with the velocity. The velocity of the tool is 3.20 meters per second. We don't know what the velocity of the astronaut is, but the astronaut is moving in the opposite direction. So that's what we're given. We want to find the velocity of the astronaut. Okay, so here we're going to use the law of conservation of momentum, which says that the initial momentum of the system equals to the final momentum of the system. The initial momentum of the system just happens to be the tool. So we have the tool. They're moving in opposite direction. So the mass of the tool times the velocity of the tool equals to the mass of the astronaut times the velocity of the astronaut. And so we want to solve the velocity of the astronaut, and that's going to give us VA equals to mtvt over ma. We plug in the numbers. The mass of the astronaut, you can recall, is 68.5 kilograms. Sorry, the tool is 2.25 kilogram. The mass of the tool is 2.25 kilogram, and the velocity of the tool is 3.2 meters per second. And then we divide that by the mass of the astronaut, which happens to be given as 68.5 kilograms. That will give us a final velocity of the astronaut that happens to be, if I plug in these numbers, I get 2.25 times 3.2, and then you divide that by 68.5 kilograms, and super small number. And that makes sense because imagine a tool is trying to push the astronaut backwards, but it's in outer space, so still okay. Still some impact. So 0.1052. Okay, 51, sorry, not 2, 51. Okay, we gotta change this to 1. We need to change this to 1 right here. This is 1. Okay, so we'll put that. Oh, gotta change that. So this is 1 meters per second. Hope you enjoyed the video. Make sure you have a wonderful day. We wanted to find the velocity of the astronaut when they throw a tool in outer space. Okay, thanks. Bye.